Today's lesson will review unit conversions, stoichiometry, and limiting reagent concepts. By grade 12, you should be familiar with many of the prefixes used for metric units. The chemistry data booklet does include a small list of these prefixes that may be useful to you if you forget any of them. When converting units, you may find it helpful to line up your calculations and use conversion factors. In this question, you are asked to convert liters to milliliters. In order to do this, you will need to remember that there are 1,000 milliliters in a liter. Set up the ratio of the conversion in such a way that the units you currently have are on the bottom, and then the units that you want to have are on the top. This way, you will end up canceling out the liter units and will be left with milliliters. The same strategy can be used with rates. If you want to convert kilometers per hour to meters per second, you will need to use two conversion factors. The first one to convert kilometers to meters, and the second one to convert hours to seconds. There are 1,000 meters in 1 kilometer, so that is what I need to use to cancel out the kilometers. I place the kilometers on the bottom of the ratio to cancel out the kilometers on the top of the original unit. There are 3,600 seconds in 1 hour, so I will use this factor to cancel out the hours. I orient my ratio with the hours on top so that I can cancel out the hour unit that was originally on the bottom. This leaves me with meters per second. These are the steps for stoichiometry. You cannot begin a stoichiometric problem without first writing a balanced equation. This is always the first step. After that is completed, write the chemical amounts that you know right below the equation. This will help you figure out what you need to calculate and solve for. Then you can begin solving the problem by calculating the number of moles of your known substance, and then use a mole ratio to determine the number of moles of your unknown. Once you have the moles of your unknown, you will complete one last step to determine the final answer as asked for in the question. In this question, you are asked to determine the concentration of sulfuric acid. The first step of writing the balanced equation is shown. Right below the equation, I have written the known quantities and a C below sulfuric acid to show that I am trying to solve for the concentration. The next step is to calculate the number of moles of my known. I will need to use the concentration and volume of potassium hydroxide to calculate the moles. Then a mole ratio of the coefficients from the balanced equation is used to determine the number of moles of sulfuric acid. Finally, the moles and volume of sulfuric acid is used to determine the concentration. One important thing to remember from Chemistry 20 is what to do when there are two substances with known quantities. Which one should be used in the stoichiometric calculations? The answer is the limiting reagent. To figure out which substance is limiting, begin by calculating the number of moles of each. This question gives the mass of copper and silver nitrate. According to the balanced equation, 1 mole of copper reacts completely with 2 moles of silver nitrate. To determine which reagent is limiting, convert the reactant quantities given into moles. You will now need to test one of these values using the mole ratio from the chemical equation. Assume that one chemical is completely used up and see if a sufficient amount of the second chemical is available. If copper is the limiting reagent, then the amount of silver nitrate required would be 0.315 moles. Since there are only 0.118 moles of silver nitrate, there is not enough to use up all of the copper. This means that silver nitrate is the limiting reagent. If you were asked to complete more calculations, you would need to use the number of moles of the limiting reagent to do so. This brings us to the end of our very short unit of Chemistry 20 review. Please proceed to the September 7th quiz.